We're going to continue our talk of statistics by going on to normal distribution. We just finished talking about histograms, and in histograms our data can be distributed or spread out in different ways. Our data can go to the left, our data can go more towards the right, where it's higher on the right, or it can be all over the place. But there are many cases when our data has a nice central value. This is called a normal distribution. In a normal distribution, we have what's called a bell curve, which is this line that goes up and around your histogram. The bell curve gets its name because it's shaped like a bell, and what's nice about a bell curve is that it is symmetric. So that means if we split our bell curve into the middle, this side of the bell curve is going to be the exact same as this side. Right, so let's break down the bell curve. In our bell curve, the area underneath of it consists of 100%. Then we're going to take the 100% and break it up into several different parts. If I drew a bell curve real quick, just to show you how it's split up. You have your line down the middle. That's going to stand for our mean. So we're going to find a mean of a set of numbers, and that will be the middle. Then it's going to be broke up into what's called 4 or 3 deviations. And we'll talk about what deviations are in a minute. Alright, so right there is my first deviation. There's my second and my third. Okay. So this area right here, that stands for 68% of the values that makes up your bell curve. Right. If we add on our second, what's called our second deviation, which would be these two lines, that means this area right here would make up 95% of your numbers that are in your set. And then if we add in our third deviation, which are these two lines, that means all this space underneath makes up 99.7% of the numbers in your set, or numbers that can fall in your set. I'll show you a chart here in a second that breaks that down even more. The bell curve determines the probability that a single data point will fall in the given range of possibilities. Here's a better look at the bell curve I was just talking about. Notice we have our mean is in the middle, it's our middle line, and then we have two standard deviation 1 lines, we have two standard deviation 2 lines, and we have two standard deviation 3 lines. Okay. I'll show you later with the calculator how to find the standard deviation, so we're not going to worry about that right now. What you need to know are these numbers. That our bell curve is symmetric, so that means if we go in the middle, when we work out, we're going to have the same numbers as they work out. 34.1, 13.6, 2.1, 0.1%. Right? What these numbers mean, that if I drew a bell curve for a set of values that given in this interval from this number to this number, 34% of the numbers will fall in there. If I said between this interval and this interval, 68% of numbers of a given set will fall in this area. Okay? So that's what we need to concentrate on, or what the percentages are. Let's talk a second about for what these little funky letters look like. On this first one in the middle, it kind of looks like a U. This is called mule. It's just a Greek letter, and it stands for mean. Right. And this, it looks like a O with a little hat. Right. That stands for sigma, and that stands for deviation. So that's where those little funky letters come from. Alright, so what is standard deviation? That's just shows you how much variation or dispersion from the average exists. It's basically your standard deviation is how spread out your data is. Once again, I'll show you how to do this with a calculator, so we won't actually have to do it by hand. If we have a small or low standard deviation, that means our data is really, really close together, that our numbers are close. And then the higher it gets, that means our standard deviation is more spread out. Alright, so let's go through a problem here. We're going to make a bell curve. We have a list of numbers here on a recent test. Ignore that they're hyperlinked. First thing, before we can draw a bell curve, we need to find the mean and the standard deviation. So I went ahead and found the mean and standard deviation. Once again, I'll show you how to do this using the calculator later. So my mean is 85, and my standard deviation is 10.5. Okay, don't worry about how I got those numbers right now. I'll show you later. Okay, so my mean is the middle of my graph. It's 85. The standard deviation means that's how many spots I go from my mean. So if my mean is 85, my next line, my standard deviation 1, is going to be 85 plus 10.5, or 95.5. And then also on the other way, you have to subtract it. So you take 85.5 minus 10.5 would be 74.5. Okay, and then you keep going down. So my standard deviation 2 would be 74.5 minus 5. 10.5 would be 64. Okay, and then on my other side, I want to go up. So 95.5 plus 10.5 would be 106. Alright, so when I'm drawing my bell curve, the top of my curve should be at my mean, and then it should be even on both sides. Now it doesn't have to be perfect, but as long as it looks something like that, which obviously is not perfect at all. Alright, don't forget what these, I need to know what these percentages were. Alright, that's what's important. So beside when you looked at your bell graph on the previous slides or on your paper, we said this number was a 34%, this number was a 34%, this number was a 13.7%, and this number was a 13.7%. Alright, so what this says is, from the grade 74.5 to the grade 85, 34% of people fell in that category, in that interval. From 64% to 75 or 74.5%, 13.7% of grades fell in that category. From 74.5% to 95.5%, 68% of the test grades are in that category. I just did 34 plus 34. Okay, that's why you have to know those percentages. Right? Our question here says how many scores are within one standard deviation of the mean. So our mean rate is right here, and our first standard deviations are right there. So I would want to take this percentage. 34 plus 34 is 68%. So 68% of our grades always fall within one standard deviation of the mean. How many scores are within two standard deviations of the mean? So that's when you would take this deviation plus this one, plus this one, plus this one, and you would get the 95%. So 95% of your grades would fall in this area of the bell curve. So we found the percentage. Now we need to find out how many numbers actually fall in that percentage. We have 26 numbers. If 68% of our 26 numbers fall in that curve, or in that part of the bell curve, we need to do 26 times 68%. You change 68% to a decimal, which would be 0.68, and 26 times 0.68 would give you about, it's a little over 17 and a half numbers, so we'll say it's about 17 of those grades. We want to find out how many scores were within 2 standard deviations. We already found our percent, like we said, so we need to take 26, how many numbers we had, multiply it by 95%, which is the same as 0.95, and 26 times 0.95 is about 24. A little over 24. It's about 24.7. So about 24 grades, 24 out of 26 fell in that first 2 standard deviations.